Suppose we are interested in evaluating the integral of x cubed divided by square root of x squared plus 4 dx. Regular substitution doesn't help here. What are we going to do instead? We're going to use trig substitution. The trig substitution that we're going to use is tangent. But to simplify the quantity inside your radical, tangent itself doesn't work. It needs to have a coefficient. So trigonometric substitution. We're going to use x to be 2 tangent theta. Why 2 tangent theta? Because on the denominator, you have square root of x squared plus 4, which is square root of, if you raise it to the second power, you get 4 tangent squared of theta plus 4. Then you can factor out 4 and you get 1 plus tangent squared of theta. So you end up with 2 times square root of 1 plus tangent squared of theta, which in turn is secant squared. So you have 2 square root of secant squared of theta, which becomes 2 secant of theta. Now, if you have x equals to 2 tangent theta, what is dx? In order to calculate dx, we're just going back to what we learned before. When x is 2 tangent theta, dx is 2 secant squared of theta d theta. So we have all the missing pieces. Let's go back to our integral, do the substitution, and simplify as much as we can. On the numerator, we have 2 tangent theta to the third dx can be written as 2 secant squared of theta d theta. And down here on the denominator, I showed you this is nothing but 2 secant theta. So if you simplify this further, you can cancel out 2 and 2. You can get rid of one of the secants here. So your integral is the integral of 8 tangent to the third of theta times secant theta d theta. Very good. In order to find this integral, you can basically write tangent to the third as tangent squared times tangent and then use regular sub. So this guy can be written as 8 times the integral of tangent of theta to the second power times tangent of theta times secant theta d theta. So you have 8 times the integral of, for tangent squared, use secant squared minus 1, and then copy down your tangent, and then you have another secant to add here, and then use regular sub. All right, let u be secant theta. So now use regular substitution. Let u be secant theta. So when u is secant theta, remember that this can be written as 1 over cosine theta. When you're finding du, this is basically 0 times cosine minus sine. You get sine theta divided by cosine squared of theta. D theta or du is equal to sine divided by cosine times 1 over cosine d theta. So du, as you can see, is equal to tangent theta, secant theta, d theta. Do we have it? Yes, this guy is just right here. I have du. So my integral is 8 integral of u squared minus 1 du. Which is super easy to deal with. This integral is equal to 8 times u to the third divided by 3 minus u plus c. Okay, my original integral is not in u, it's not in theta, so I have to make some adjustments now. Remember that your x is 2 tangent theta, so let us copy this guy down and move it here. So for now, we have the following. This is equal to 8 times my u is equal to secant theta. So this guy is a third secant to the third of theta minus u, which is just secant theta, and then plus constant of integration. Okay, but what is secant? All right, now the question is, how do you make some adjustments and rewrite this in terms of x? So since tangent of x, tangent of theta is equal to x divided by 2, from the right triangle, what do we have? This is my right triangle. Let me use a different color for this guy. This is my theta, my x, and then my 2. So this guy, the hypotenuse, is basically 4 plus x squared. So if I want to write secant, which is 1 over cosine, secant of theta, which is 1 over cosine of theta, is equal to, well, you have square root of 4 plus x squared divided by 2. Perfect. So my integral is now a third secant to the third. Ooh, that's a big number. Square root of 4 plus x squared divided by 2 to the third minus secant, which we know is square root of 4 plus x squared divided by 2 plus constant of integration. So we get 8 divided by 3 times. Here you can just raise this guy to power 3 or leave it as it is, or simplify it as much as you can. That's totally up to you. Or you can write it in fraction form. You get 4 plus x squared to power 3 halves divided by 8. So you can get rid of 8 and 8 minus, here you have square root of 4 plus x squared divided by 2 plus c, or our final answer can be written as 4 plus x squared to power 3 halves divided by 3 minus square root of 4 plus x squared divided by 2 plus constant of integration. A lot of steps, but we made it. Okay, yeah, I forgot to multiply 8 here, so it should be 4, am I right? 8 thirds, you need to have 8 here. You need to have 8 here, so it should be 4. Okay, perfect. Forgot my denominator here. Minus 4. Very good. So let us go back up and summarize what we did. You had the integral of x cubed divided by square root of x squared plus 4 dx. We used the trig substitution of 2 tangent theta. Why is that? Because our denominator becomes 4 tangent squared plus 4. So you can basically factor out this 4, and you can write this as 1 plus tangent squared, which is familiar to us. This is secant squared of theta. So that's the reason we are taking 2 tangent. We are not using sine here. If you use sine, you cannot get rid of sine. So our option here, a good option here is 2 tangent theta. So after we simplify the numerator and the denominator, it becomes the familiar integral of 8 tangent to the third of theta secant theta d theta. Well, since you have tangent and secant, and you remember that if you have secant, the derivative of secant is tangent secant, so it's easier to break tangent to the third as tangent squared times tangent. Then you end up with tangent theta times secant theta d theta, which is your du. So inside trig substitution, we used a regular substitution. In our regular substitution, we basically calculated the integral of u squared minus 1 du, and then we substitute everything back because our u was secant theta. But our answer is not sufficient because our original integral was in x. So we have to go back and use the hypotenuse to find cosine theta. Why? Because we have secant. So after doing all of the algebra, we found that secant is square root of 4 plus x squared divided by 2. We substitute everything back for secant because we ended up with secant to the third and secant down here. The rest is algebra. So our final answer is written in x, and we're happy about that.